So what I'm going to do is I'm going to solve this one using our elimination. I would like to be able to add these things together, or a linear combination, and be able to have one letter cancel out. So in order to do that, I'm going to have to multiply at least one of these equations. So we're going to pick a letter, either X or Y. Doesn't matter which one. Somebody pick a letter. Y. So let's look at our Y's. I would like them to have the same number, but with the opposite signs. So what can I get 3 and 6 to be that are going to be the same number? 6. I don't even have to do anything to the bottom one. I can make the top one be a 6. What am I going to need to multiply this whole equation by to make that be a 6? I was going to say, since we already have a minus down here, I am going to keep this one as a positive, so I am going to do it as a positive 2. You can totally do it with a negative 2, but that's going to make an unpleasant amount of minus signs. So I'm going to take that top one and multiply it by 2. So we're going to have 4x plus 6y, that's a y, equals 9 times 2, which is 18. So we have to multiply absolutely everybody, all 3 pieces. Then I'm going to bring the bottom one down and just write it underneath. Not changing anything on it. My minus 4x, my minus 6y, and my minus 18. When we're doing our elimination, that's when we're going to come through and add them together old school style, where we're doing like columns. So if we do 4x plus negative 4x, what are we going to have left? Nothing. I get 0 x's left. What about if I did 6y plus negative 6y? Nothing. All right, no y's. How about 18 plus negative 18? 0. So I wind up with 0 x's and 0 y's equals 0. So that's 0 equals 0. Does 0 equal 0? Yeah, it does. 0 equals 0. That's a true statement. So what this is telling me is that no matter what x is, no matter what y is, we are going to get a true statement. So we're not actually getting a point where these cross. So let's see what that means if we look at trying to graph these and what that's going to stand for. So there's a few different ways you can approach it when you're graphing things in this standard form. You can either solve it around in a slope-intercept form and do that. That's totally fine. Or we could do our x and y intercepts. When we're doing x and y intercepts, that's when I say, okay, if x is 0, that means this 2 times 0 is going to go away. So if we do x is 0, 3y equals 9. Solve that bit. What would y need to be for 3y to equal 9? 3, right? 3 times 3 would give us 9. So if my x is 0, my y has to be 3. If my y is 0, so I substitute in 0 for y on this guy. 3 times 0 is 0, it goes away. 2 times x equals 9. 2 times what would equal 9? Yeah, it'd be about 4.5. So it's going to be decimally and icky. 4.5. But that would be getting our x and y intercepts, which is a totally valid way to do it. I'll do the other one, putting it into slope-intercept form so we see both ways. But what that gives me, my 0, 3, that gives me my y-intercept when my x is 0. That's this guy right there. And my 4.5, 0, that's this guy right there. I have my y-intercept, I have my x-intercept, and from there I could get the line for that particular piece. And it's going to give me a second to get my chunky style line. I can connect them up and it's going to look like this. There we go. So that's the line we get from that top one by doing my x and y intercepts. With this second one, if I want to put it in slope-intercept form to do it, you guys have a little bit more space on your page, but I don't. That's when we want to get our y equals mx plus b if you want to do it slope-intercept style. So guys, gentlemen, thank you. If we want to get this in a slope-intercept form, we need to get the y by itself. So I'm going to start by adding my 4x to both sides, because I would really like that to be on the other side. If you have a question, I'm happy to answer it, but otherwise the side conversations do kind of need to stop. So we have our 4x and a minus 18. I have like no space here. Oh my gosh. So what we would need to do to get the y by itself is I'm going to need to divide absolutely everything by that negative 6. So we're going to have our y equals 4 over negative 6x minus 18 over negative 6. So we're kind of solving it out that way. I'm going to bring this up over here because I know I'm straight up over the lines. And we're going to simplify it just a little bit. So we'll have our y equals 4 over negative 6. That was the same thing as negative 2 over 3 because they're both divisible by 3. 2, excuse me, both divisible by 2. 2 over 3x minus 18 divided by minus 6 is a positive 3. So if we put this in slope-intercept form, we're starting at our y-intercept of positive 3, which I'm going to do with a very, very light blue because it's right there. I'm going to go even lighter. I'm going to do a white right there. It's straight up at the same spot as my purple line. And then it's going to go down 3. It's going to go down 1, 2, 3. Down to, excuse me, sorry, brain is not braining. Down to right 3 with our slope of down negative 2/3. Down to right 3 is going to give me a dot right here. If I go, just because these aren't showing up. Down to right 1, 2, 3. It's right on top of that line. So if I was to graph this, not saying if, while I'm graphing this, if I put this directly on top of the other line, that is not what I meant. Give me back my line tool. I don't need to make an oval. Give me my line. It's actually going to wind up kind of like that, where it's directly on top of the other line. I have both lines graphed here. One's purple and one's blue. But they're directly on top of each other. So that's what they're wanting us to try and notice in these. What do we notice about the lines is that I have the same line twice. These two equations are for the same line. So the tricksy question here is what is the solution? Where do the lines intersect? How many solutions exist? Part D question on that page. What do we notice? Where do they cross? Everywhere. There is never a place where they're not crossing. So how many solutions do we have here? An infinite number of solutions. This is one of those times when we get infinitely many solutions. There is not one answer. Infinitely many solutions. Because they are the same line. Okay? So sometimes we will have where we do not get an actual answer. And if we're solving algebraically, that's what this is going to look like. We will wind up with something inherently true, like 0 equals 0, or 4 equals 4, or 7 equals 7. So all of my letters cancel out, and we're left with something inherently true. Okay? It's been a hot minute since we saw those. Questions on that one? Okay. Similar vibe. Next one. Next page. Number 2, page 35. Same kind of vibe. Same vibe. As far as the question E goes, this is literally the only time they're going to use those words, so I am not concerned about those words or what those vocabs are. Because honestly, I have to look them up every year to remember what they are, which means they clearly do not come up enough. So don't worry about question E. It won't come up again. So let's look at this one. We've got x minus 2y equals 8 and 3x plus 6y equals 6. So I'm going to again start this one out solving algebraically. So we can look at this one and we can do this one either with elimination or with substitution. It's about equally difficult for both of them. Do y'all have a question back there? Questions? Okay, then the side quiz conversations need to stop. You got a question? I'm happy to answer it. But the side quiz conversations are very distracting. So we can solve this one algebraically. Again, it does not really matter if we use substitution or elimination. This one is set up fairly similarly of difficulty level for both, because I could either multiply the top one by -3 to get my x's to eliminate out, or my y's, or I could add 2y to both sides to get an x equals and do it substitution style. That's the way I'm going to go, just to let us practice the substitution. So I'm going to take this guy and I'm going to make this be an x equals. So to do that, I'm going to add 2y to both sides. If you already started working while I was talking and you started doing elimination, you should still wind up with the exact same kind of vibe that we get. So we're going to have an x equals 8 plus 2y, or you can put 2y plus 8. Either way is fine. What this lets us do is we can take this chunk and substitute it in place of the x here. I'm putting it in place of this. I know x equals that piece, so I'm going to shove that piece in place of the x. So what that's going to give us is 3 times, instead of the x, I'm going to put in what I know x equals. My 8 plus 2y. And then we have to finish the rest of our pattern. Our minus 6y equals 6. Everyone see where we got those pieces from and how we got that? Because that's usually the hardest part of the substitution, is figuring out which pieces go where. After this, we're going to be simplifying stuff. So all we're going to need to do is we're going to distribute here to get our 3 times our 8, which is going to be our 24, plus 2 times y times 3, which is going to give me 6y. And then we have our minus 6y equals 6. What do we notice here on this step when I come through to simplify? My y's cancel. Those guys are gone. I have 6 yaks and I'm selling 6 yaks. Or I have 6 yogurts and I lose 6 yogurts. Or I eat 6 yogurts. I get rid of them. They're gone. I have none left. What we wound up with is a statement that says 24 equals 6. Does 24 equal 6? No. Even if x is 12, 24 does not equal 6. If y is 411, 24 does not equal 6. If x is 0.89432, 24 does not equal 6. So we get something that is inherently false. This is not true. So what do we think might be happening with these lines? Yeah, these are going to be parallel lines. These are two things that will not touch ever, 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 ever. Never, ever, ever. So if we look at this when we are graphing, thank you, dear. And again, we can do this again either using our x and y intercepts. We can solve these around into slope-intercept form. Either way is fine. I'm going to do the top one for sure with x and y intercepts because it's honestly really easy. Because if my y is 0, my x is going to be 8. So my top one up here, we're going to have a y-intercept at 8. Up here. My x-intercept we get by substituting in for Oh, that's what I just did. Sorry, I just definitely flip-flopped that. We substitute in 0 for y, and we got our x-intercept. X is 8. If x is 0, to find my y-intercept, we get negative 2y equals 8. So if x is 0, my y is going to have to be a negative 4. So you can write those out. You could put this into slope-intercept form. You can do any number of options when it comes time to graph these. When we're in standard form, sometimes it's really easy to get our x and y intercepts, as long as we're being careful and paying attention to which one I'm writing down when I'm writing down and talking at the same time. So this one's our y-intercept. We sub 0 in for x. And this one's our x-intercept, where we sub 0 in for y. That gives us our line that's down here that goes from here to here, like that. And it keeps going forever. We just are lazy and don't enter our arrows. The other one, you can do it very similarly. I'm not going to use the pink, so I'll use that for a thing. Or you can do that and find your x and y intercepts, or you can solve that around into slope-intercept form. I'm going to do my x and y intercept on this one because it's not bad, and I want to go through it properly again. So to get my y-intercept, we sub in 0 for x. To get my x-intercept, we substitute in 0 for y. So if I have 0 for my x, so this one up here, I know my x is 0. I can substitute in 0 here. That means 3 times 0, that's 0. It goes away. We get minus 6y equals 6. So my y would need to be negative 1. So we're going to have a point at 0, negative 1. There we go. So 0, negative 1 is right there. If I substitute in 0 for the y here, so we'd have our 6 times 0, that's 0. We get 3x minus 0 is 6, which is the same thing as 3x equals 6. So my x would need to be 2. Okay, so it's not a way that we have graphed a ton since Algebra 1, but it is a valid way of graphing. You can also just switch these into slope-intercept form and go from there. I will practice that one for us on the next one. We'll get them into slope-intercept form and look there. But what we're seeing here is we're winding up with parallel lines. So what's our solution? None. We don't have one. This has no solution. Our solution is where they cross. They do not intersect. They do not cross. There is no place where that happens. That's what happens when we get a falsehood like this. We get something that will never be true, no matter what x is, no matter what y is. It doesn't matter if x is 3 million, y is negative 427.2. It doesn't happen. It doesn't work. So we get parallel lines that have no solution. And you don't have to graph like this. It's just one of those things. It doesn't take up a ton of space, and it's not super duper complicated. But if you want to switch to slope-intercept form every time, that also works. It's totally fine. I don't care how we graph. We just need to be able to graph. Okay. We're going to do one more of these. Questions on this one before I change the page? Okay. Let's look at this one. This is our last step for today. So we're going to look at them algebraically. We're going to look at them by graphing so we can see what we start to see here. So we can do this either out with substitution, or we can do this with linear combination. Again, it's set up pretty nicely for either one. Either way, we're going to have a step to get started with. What do we want to do? Why don't y'all pick on this one? For our algebraically solving. Do you want to do substitution, or you want to do our elimination?
Elimination.
Ooh, a blend. I need a tiebreaker. You were the same person who said substitution last time. Yeah, like you think I don't know your voice already? Come on. I appreciate the passion. Let's go substitution. I'm going to blend it also with my slope-intercept form. Oh, snap. What? If you want to do elimination, you should get the exact same answers as us. It does not matter which technique you use. So I'm going to take this one and get it into my slope-intercept form first. So we have minus x plus y is minus 2. Well, in order to get this to be in my slope-intercept form, I need to get my y equals. So I'm going to go ahead and add x to both sides here. That's an x. So that's going to give me a y on the left-hand side all by itself. And if I have minus 2 plus x, that's the exact same thing as having x minus 2. Because I have a positive x and a negative 2. It means the same thing. I'm actually going to put this one in slope-intercept form as well, just so we can practice that and do the substitution that way. So on this one, to put it in slope-intercept form, what we would need to do is we would actually need to subtract our 3x. I already have 3 x's on this side. I need to get rid of them. I want my y to be by itself. So we would need our y equals, and then I have a minus 3x and a positive 2. So I could write this as minus 3x plus 2. So we can write it that way. And we can do our substitution either to either equation. We know that the y is going to equal x minus 2. I can either come back here and substitute it in that spot, or I can use this one and substitute it in this spot. It genuinely does not matter. I'm going to use the one that I just wrote just so we can practice a little bit more. So I'm going to take the fact that I know my y is going to mean this. That's what we want it to be. And so I'm going to substitute that in place of this y. So I'm going to take my x minus 2 in place of that y. So we're going to get x minus 2 equals our minus 3x plus 2. We have our two equations here. They just both happen to equal y. So what I do is I set these two pieces equal to each other. I want to know when my y equals my y. So then we need to solve this. What can we do to solve this? You can subtract 2. Let's do it. It's minus 2 from both sides. So that's going to give me x minus 4 equals minus 3x. Then what do we want to do? Yeah, we can subtract an x from both sides. Minus x on this side, minus x on this side. That's going to give me that my minus 4 equals minus 3x minus x is a minus 4x. How do I get my x by itself? Divide by negative 4. What is negative 4 divided by negative 4? 1. So my x equals 1. That's awesome. Does that help me find my whole solution? Because what is our solution going to be here? Let's take a look at our graphs. I'm going to go ahead and graph it before we finish talk about the solution here. So let's graph our two lines so we can see what's going on here. Y equals x minus 2. So I've got a y-intercept. My plus b is negative 2. So my y-intercept is at negative 2 on this one. And my slope, the number in front of my x, my mx, I've got a 1. So I have a rise of 1 and a run of 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You do not have to do dots from edge to edge, but the more dots you do, the easier it is to connect them up without your ruler going crooked. And especially since we are looking for solutions, we do need our lines to be pretty decent. So the more dots you do, the easier it is to get your line straight. If you ever need a ruler, I have them back. Surfing Cat holds all the rulers. So that gives us our top line, that blue line. Let's look at our green one. It's a very similar vibe, except this time we've got our mx plus b, and my plus b, that positive 2, gives me a y-intercept up here. Our slope being negative 3, how are we going to move with a slope of negative 3? How do I get my next point? Perfection. Down 3, right 1. Down 3, right 1. Down 3, right 1. And again, the more dots we have, the better. I could also go up 3 and left 1. That still gives me that negative slope. Up 3 and left 1 works just as well. And then all we need to do is connect up our dots. We can see our line here, which will not go all the way up to the top. It's being a grumpy ass, but that's okay. Where is our solution? 1, negative 1. So it's our point 1, negative 1. But in our algebraic, all I got was the 1. How do I get the other piece of my solution to get my 1, negative 1? If we're looking algebraically, how do I get that other part? All we got was our x equals 1 here. How can I figure out what the y is if I don't graph it?
Plug it into the equation.
I've got a y equals equation up here. I could either substitute that x into this one, or I could substitute my x into this guy. Either way, if I want to know what my whole solution is, I'm going to need to do that. We're going to need to take my y equals and substitute in that x that I know is 1 minus 2. I'm using the top one. Well, 1 minus 2 gives us negative 1. And that tells us all the same pieces that we found when we graphed it. So solving it algebraically gives us the same answer without needing to do the graphing part. Because sometimes we will have things that are decimals or fractions or kind of gross. And we can get those answers significantly more accurately by doing our solving algebraically. So more often than not, we are going to solve solutions algebraically because it is more accurate and easier to deal with icky numbers sometimes. Okay? Questions on those three? This has been a minute since we solved some systems. Okay. Let me see if we have time to do this thing. Figuring out the thing. Hang on just 1 second. Okay. We have like 6 minutes left. I will save the last thing for us to do next week. It's not a big deal. Okay, so I'm gonna skip over that. That's gonna be it for today. All right. So So thinking about those systems, we're gonna keep working with systems. Next week, honestly, for the rest of this chapter, everything is systemsy. But we're gonna really start getting into like story problems and writing equations and using it for analysis next week a lot. So I was like, if you flip through the book, we really only have one more page where they just give us equations and they don't give us a paragraph. Everything after the next page is all story based. Okay? Yes, dear.
So when we find our solutions and stuff, what we do is we do it this way. I know how to get to this point, but however we word it is that's what's confusing me sometimes. Like, is there like an easy way to word it or something like that? Because when you explain it to me,
Right.
I got it, but
It's just finding the x and y intercepts is what it is. The only thing it is. It's just sometimes when I'm talking, my words come out of my brain faster than my mouth can keep up. And
I
yeah.
was trying
Yeah.
to understand because I understood what you said somehow, like because I got it.
Right,
Like,
right. Yeah. Not really. It's just kind of. And so if I don't care what you call it. If you just want to call it the weirdness that she does, works for me. It doesn't have to have a name. Okay. As long as we know what's happening. I don't care what we call it. We can call it George's line craziness for all I care. Okay. So yeah.